This video we will be going over section 1.3, which is on the other trig functions. Section 1.2, we introduced the idea of sine and cosine, which are in a lot of ways the basic two trig functions, but based on ratios of sine and cosine, which you'll see, ratios means division, we can make four more, and we'll see pretty quickly that tangent is the one that's going to be very different and more important. I also mentioned in the last video that tangent popped up inside there because it is so important. And these other three, cotangent, secant, and cosecant, are all based on flipping sine, cosine, or tangent. All right, so we'll see the definitions in a second. And then really the main topics in this section is just kind of doing what we did last section. We want to be able to evaluate the trig functions using the reference angles in the unit circle. We want to make sure we know how to do this in the calculator because there's a tangent button, but there isn't in most calculators going to be a cotangent, secant, and cosecant button. You have to make sure you know how to do that. And then the last thing is tangent values on the unit circle. This is something that pops up more so in section 2.2 when we get there. We'll see how to figure out some values of tangent on the unit circle and at the end. Right, so the first section, the four trig functions, tangent, cotangent, secant, and cosecant. Right, and when we begin studying trigonometric functions and their relationships to right triangles, which will be in the next section, it will be convenient to introduce the other four trig functions called tangent, cotangent, secant, and cosecant. All right, they are defined as follows. So theta, let theta be any angle. You can still do degrees or radians, just whatever the question's in. This first one here, I have just the symbols written, but I'll write in English what this is. TAN is tangent. This is tangent of theta. And tangent of theta is defined to be sine of theta over cosine of theta. Like I said, this is the big one. We'll definitely use the other three throughout the class as well from time to time, but sine, cosine, and tangent are the three big trig functions. So you really need to memorize this. Just remember it's sine over cosine. Another way to kind of think about it, and I'm not necessarily that you would do this, but some people have liked thinking about tangent this way, since sine is the y value and cosine is the x value on the unit circle. Some people like y over x, and the reason they like that is this is sort of like the slope of a line. Y2 minus y1 over x2 minus x1. Ultimately, I just remember tangent is sine over cosine, but this is a definition. It doesn't come from anything else. You just have to memorize it. Cotangent is the next one, the COT. And there's really two ways to think about this one. One is that it's cosine of theta over sine of theta. There will be times in this class we want to use that one. There will also be times in this class where it will be easier to refer to it as 1 over tangent of theta, right? Flipping tangent. In general, if we have some number and we put 1 over it, it's talking about flipping or doing the reciprocal. So cotangent is flipping or doing the reciprocal of tangent. Right. Now, secant of theta is this SEC, secant. And the way we want to think about secant is 1 over cosine of theta. Very helpful to use the same idea. It's flipping or the reciprocal of cosine. We saw a little bit with the unit circle that sine and cosine of angles are often fractions. That's why I like to write flipping, but it's also helpful to write reciprocal. Right, but secant is the reciprocal or flipping of cosine. The last one is cosecant. The letters we use for that are CSC. And cosecant is defined to be 1 over sine. So cosecant of theta equals 1 over sine of theta, and we think about it as flipping or the reciprocal of sine. All right. The one thing at the beginning most people get backwards is these two, because you kind of want the cosecant to go with cosine, the one without the co to go with the one without with co, secant to go with sine, but it is backwards. If you wanted to look up on Wikipedia, there's actually a historic reason why this is true, but really what you want to do is remember these 4 things. Tangent is sine over cosine, cotangent is gotten by flipping tangent, secant is gotten by flipping cosine, cosecant is gotten by flipping sine. Right, but once again, the thing that I said about the beginning, you really got to remember tangent's definition and then think about these 3 as what is being flipped. Anytime we want to figure out cotangent, secant, or cosecant, that's pretty much the way I'm going to ask it, is what is being flipped. All right. One thing that I like to mention here, we'll see it in problems, but I just like to go ahead and preview that, is because you have fractions now, if we know we cannot divide by 0, so there are going to be some of these where their values do not exist, meaning sine of 0 equals 0 from the unit circle, but also because it's the y value. If you don't have that memorized yet or quite there yet, that's okay. But since sine of 0 is 0, for example, we'll see that cosecant of 0 is undefined, or DNE, because it's 1 over 0. We cannot divide by 0. All right, so that's just a warning. When we do it, either in our calculators or by hand, or check it in the calculator, getting an error makes sense for a lot of these. All right, so we really just want to practice the unit circle some more with our new definitions. This section here, we want to evaluate trig functions using reference angles and the unit circle. For the following angles, give the exact value of the 4 new trigonometric functions. If the trigonometric function does not exist, write DNE. Right, so in our first one, theta equals 3 pi over 2. Right, and we're going to do it exactly like I've been doing in the last section. Draw the picture, see where it is. We're dealing with radians here, so I'm drawing the radians picture. And 3 pi over 2 is actually on one of our axes. It's the negative y-axis. Now remember the way we dealt with this, there wasn't any reference angles. We just point out the x and y value. Because we're on the unit circle, what's going to happen is one of x or y is going to be 0, and then the other one's going to be 1 or negative 1. For this one here, we're on the negative y-axis, so x is 0 and y is negative 1. Right. In order to get any of these secants, cosecants, and so on, you need to first figure out what sine and cosine are at your angle. So we got cosine of theta equals 0, our x value, and our y value, we got sine of theta equals 0. Now it's up to you how you think about this. I like to think about the flipping thing. It's best for me. You can think about the reciprocal. Sometimes when they're whole numbers, it sounds kind of weird to flip it, but it's really not too terrible. Secant of theta, that's what we get when we flip cosine. And cosecant of theta is what we get when we flip sine. So what we do here, we don't actually have a fraction, which is okay. We can always think of our fractions being over 1, a whole number being over 1. I just realized that I wrote sine of theta equals 0, and it's clearly -1. But if you want to always do the flipping thing, just always think of a whole number as a fraction over 1. So that way we can think about flipping them. That's certainly true. So secant of theta, we flip cosine, we flip 0 over 1, we get 1 over 0. Now, like we mentioned before, dividing by 0 is bad. This one is going to be d and e. We cannot divide by 0. And then cosecant of theta, we flip sine. Sine is -1 as a fraction, -1 over 1. If we flip it, we get 1 over -1, which is still -1. So cosecant of 3 pi over 2 is -1. Now, to get the other two, tangent and cotangent, you just use their definitions. Tangent's sine over cosine. Sine, I'm going to use just the whole numbers here because it's going to make a fraction itself. Sine of theta is -1. Cosine of theta is 0. And just like in part 1, this is a d and e. We cannot divide by 0. So we've got an example here where secant of theta and tangent of theta are d and e. Now, this is one of the problems where you probably want to use that cotangent's cosine of theta over sine of theta. You know, if for no other better reason, you've already figured out each part. But if you base cotangent as flipping tangent, it might not make sense if you're just looking at d and e here. How do we flip d and e? So just use the definition. Cosine of theta is 0. Sine of theta is -1. And 0 divided by anything is 0. That is fine. We get 0. All right, so we've got our 4 values here. All right, once again, just using the definitions. Oops. Nothing more than that. And you can kind of see how we built it off the unit circle because that's how everything is defined. Anytime you do something with your trig functions, you're almost always going to figure out sine and cosine first, even if you don't necessarily need them for your final answer. All right, we'll go down and do another one. Oops. Same question here. We want to figure out all the new trig function values, secant, cosecant, tangent, and cotangent, and our angle is 11 pi over 6. Okay, now one thing you want to notice right away, this isn't going to be on an axis, but it is between 0 and 2 pi. We can visually see it. And let's go ahead and draw everything out. What quadrant is this in? And we're answering the same questions we did last section when we did sine or cosine. We want to know what quadrant it's in. We want to know its reference angle and everything. All right, the goal is to first figure out what sine and cosine of theta are. Okay. Now 11 pi over 6 is in quadrant 4. Again, if you're still not comfortable totally with that, look back at the previous video. You can just type it in your calculator, see 11 pi over 6 is going to be between 3 pi over 2 and 2 pi. We got 11 pi over 6. and the reference angle we get by doing the bigger angle minus the smaller angle. 2 pi minus 11 pi over 6. And simplify that to one fraction. Multiply the 2 pi by 6 over 6. Get a common denominator. And 2 pi times 6 is 12 pi. Minus 11 pi is 1 pi. Or just pi over 6. So we got, it's in quadrant 4. It's a reference angle. Is pi over 6. Now, once again, if you want to go back to how we were doing it a little bit last section, you can think about what is this in degrees to figure out what sine and cosine are at this angle. And pi over 6 is the same as 30 degrees, if that helps you. All right, so what we're going to do is we're pretty much doing last section's problems first. We're figuring out what sine of theta and cosine of theta are, which we can do now that we have its quadrant and its reference angle. And then from there, we can figure out the rest. All right, so in quadrant 4 down here, y is negative, which means sine of theta is negative, and cosine of theta, x, is positive. And so this is negative in quadrant 4. This is positive in quadrant 4. And then the reference angle being 30 degrees, that's the smallest one. So remember, sine starts at 1 at the smallest angle inside the square root. And we always have over 2, but I'm going to keep it as just 1/2. And then cosine starts at 3 inside the square root, and it's always over 2. But you can also check in your calculator, does sine of 11 pi over 6 and cosine of 11 pi over 6 actually equal these numbers? All right, so now that we have this stuff, we can do the problem pretty quickly from here on out. All right, secant of theta, we want to remember its definition. Secant is what we get when we flip cosine. Cosecant is what we get when we flip sine. And this is really, you know, where you can see the flipping thing come into play. This is very useful. Think about it flipping more so than the reciprocal, or by its definition specifically. All right, so if we flip cosine, we do not do anything to the SIGN sign. If it's positive, it's positive. If it's negative, it's negative. We just flip the 2 in the square root of 3, and we get 2 over the square root of 3. And this is fine. You don't need to simplify this. Rationalizing the denominator is not necessary. You're allowed to have square roots in the denominator of fractions. All right, now if we flip sine, we get negative out front, right? That flipping the fraction is not going to change that. And we get 2 over 1. And we can simplify that to negative 2. So cosecant of 11 pi over 6 is negative 2. Right, now down to tangent and cotangent. Tangent of theta is sine of theta over cosine of theta. Now what you want to do here when you write this, you'll see that it's going to cancel out pretty quickly. So when we write sine of theta on top, I like to do a big fraction bar. Put the sine of theta, what we got on top, which is negative 1/2. And cosine of theta, which we got as square root of 3 on the bottom. And the proper way to simplify this would be a fraction inside a fraction. We multiply by the reciprocal here. We do keep, change, flip, as some people know it as. Which means if we're dividing a fraction by a fraction, we keep the numerator. we changed the division to a multiplication and we flipped the denominator. And then the 2's cancel when we multiply, and we got -1 over the square root of 3. And this is fine as an answer. Once again, like part A, you do not have to rationalize the denominator when you do these. Right, but one thing I'll point out, because this happens pretty much every time we deal with tangent, is that when you have a fraction like this and you have matching denominators, meaning we have the 2 here and the 2 here, you can just cancel them out. Because when you flip them, they're going to cancel out anyway. And you get the -1 over square root of 3. Right, now to get cotangent of theta, you can do it for this one of two ways, because you actually have a fraction here. If you think about cotangent meaning flip tangent, then you can do it that way. If you think about it as cosine over sine, that's also fine. Now, I'll just do it the cosine over sine way, and you can see that it just amounts to flipping this. All right, so cosine of theta was square root of 3 over 2. Sine of theta was -1/2. Like I showed you afterwards last time, the 2's will cancel when we keep change flip. And we're left with square root of 3 on the top, -1 on the bottom. You can leave it like this, but you can simplify, because dividing by 1 does nothing, and you can move the negative sign out front of the top. We get negative square root of 3. So we can see that it is ultimately just flipping tangent. Good idea to practice both ways though, because you don't want to think about it just being one of the two ways. We're going to use both. Right, so I got one more here just as a reminder again that when you're dealing with an angle that's not between 0 and 2 pi, you got to put it there to deal with any other stuff. All right, so we got theta equals -11 pi over 4, and we want to figure out the other 4 trig functions again. Cotangent of theta is down here, but we want to put it between 0 and 2 pi. All right, we can see our angle is negative, so we're going to have to add 2 pi. The question is, how many times do we have to add it? And I started spoiling the surprise already, but I'll remind you how to figure that out one last time. If you take your angle, -11 pi divided by 4, and then you divide that by, oops, that's not a division, sine, answer divided by 2 pi. When it's negative, you take this number, whole number here, -1, but just the one part, and then you do it one more than that. So we're going to add 2 pi twice. And remember, if you do that, it just saves you a little bit of steps. So we're really adding 4 pi here. Plus 4 pi. And then we get a common denominator, multiply the 4 pi by 4 over 4. We got 16 pi over 4, and -11 pi over 4 makes 5 pi over 4. Now, once we are here, we can draw our picture. This is between 0 and 2 pi. See what quadrant it's in, see what its reference angle is, figure out sine and cosine, and then the rest. A lot of little steps, but if you kept up with last section, really the new stuff is just our new definitions. We did everything else already last section. So we got 0 to 2 pi, we got pi over 2. We got pi and 3 pi over 2. And the question is, what quadrant is theta in? But remember, we're pretty much using this as our theta. It is in quadrant 3. All right, 5 pi over 4 is between pi and 3 pi over 2. You can check that. And its reference angle, visually here, it's the angle between pi and 5 pi over 4. If we do bigger minus smaller, like we always do, we got 5 pi over 4 minus pi. Bigger minus smaller. Get a common denominator by multiplying the pi by 4 over 4. 5 pi minus 4 pi is a single pi over 4. All right, and if you want to switch that to degrees to do the next part, it is the same as 45 degrees. Pi over 4 radians is the same as 45 degrees. Now we just finish up like last time. We figure out what sine and cosine of theta are. And then plug in our new definitions. The theta is in quadrant 3, which means sine and cosine, x and y, are both negative. So we're going to have a negative for each of these. And even better is that pi over 4 or 45 degrees, that's that middle one. That's where sine and cosine both have 2 inside the square root. So they have the exact same value. Once again, I will remind you, this is pretty much what we did last section. Nothing new at this point. Now we're going to do the new stuff. We're going to write down, what is the definition of secant of theta? Well, we flip cosine of theta. What's the definition of cosine of theta? Cosecant of theta, we flip sine of theta. Right, so if we flip cosine of theta, we got our negative sign out front. The 2 goes on the top, and the square root of 2 goes on the bottom. Now, one thing you can do, once again, you don't have to rationalize the denominator here if you don't want to. But when the number in the inside of the square root matches the number on top, it does simplify quite a bit. So I'm just going to multiply by the square root of 2 over 2, rationalize the denominator. And we got negative 2 square root of 2 on the top. And square root of 2 times square root of 2 is the square root of 4 on the bottom. But the square root of 4 is the same thing as 2, which means the 2 and the 2 cancel, and we get negative square root of 2. All right, so either one of these is fine. You do not have to rationalize the denominator, like I said, but it is good to recognize when the number inside the radical matches the number outside the radical, you can simplify it. One thing I want to point out here is, since sine of theta is the same as cosine of theta, when we flip it, we'll get the same number as above, right? Because sine of theta is the same as cosine of theta here. So when we flip cosine, when we flip sine, it's all the same. We will get the negative square root of 2. Or the negative 2 over square root of 2 if you stop there. Right. Now tangent of theta, by definition, again, that's sine of theta over cosine of theta. Now if we plug these in, we got sine of theta is negative square root of 2 over 2 over cosine of theta, negative square root of 2 over 2. You can do your keep change flip here. You can notice things cancel out. Now I'm going to do the keep change flip here just because everything cancels out, and I don't want you to kind of think it's going to be 0 because everything is canceling out. Don't want you to go too fast. So we got negative square root of 2 over 2 on the top. We change our division to multiplication and multiply by the reciprocal down here. So 2 over negative square root of 2 on the bottom. Right. Now everything does cancel out. Negatives go away, square root of 2's go away, and the 2's go away. But that leaves us with 1. Right? We're canceling out a whole bunch of things with multiplication. That means it's left with 1. But this is something that makes a lot of sense if you think about, sine of theta over cosine of theta being the definition, and they're the same. Right? If we divide something by itself, it's going to be 1. 2 over 2 is 1. X over x is 1. Cotangent of theta is going to work out the same as tangent because sine and cosine are the same. Right? Cosine of theta over sine of theta is what cotangent of theta is. We got cosine of theta, which is negative square root of 2 over 2. Sine of theta, which is also negative square root of 2 over 2. And everything will cancel out and we'll get just the 1. Absolutely, this is as messy as it can get, doing all the little steps not being between 0 and 2 pi. But the point of emphasis here is 90% of what we did here was the old stuff, in my opinion. The new stuff was just the definitions, flipping cosine, flipping sine. What is tangent? What is cotangent? And then plugging in. Right, so just make a note of that over here. And do all the old stuff from 1.2 to get sine of theta and cosine of theta. Okay, that's ultimately what we did. Then use the definitions to get the new stuff. That's ultimately what we did. Most of the work was here, but you do have to memorize these definitions of what all sine and cosine and everything are. Right. This is a question that we did ask in last section, and I figured, we might as well do it with our new stuff just so you can remember and practice it more one more time. But we had a couple problems like this in the last section. We were told if sine of theta equals a number and theta is in a certain quadrant, then we wanted to find cosine of theta. But now we're going to do everything else. We're going to do tangent, secant, cosecant, and cotangent. Apparently I labeled all these as part A, but no big deal. But I will remind you, the only way you have to figure out any of this is one formula. So at this point you have one way to do that. So we need to get cosine of theta first. And the way we do that is from our identity, cosine squared of theta plus sine squared of theta equals 1, our Pythagorean identity. This is the only way to get cosine from sine at this point. All right, so we go ahead and do a couple things, right? We plug it into sine of theta and start solving for cosine of theta. The other thing I want to remind you is the quadrant tells you whether cosine should be positive or negative. And cosine is negative in quadrant 2. So when we get to that square root part where we do the plus or minus, we're going to keep the minus. All right, so let's go ahead and plug it in. We've got cosine squared of theta, what we're solving for, plus sine squared of theta. Sine is 3 over 8 squared equals 1. Go ahead and just simplify. So square this part out. 3 over 8 squared is 9 over 64. Which equals 1. And then we subtract the 9 over 64 from each side. We get 1 minus 9 over 64. And to get a common denominator here, we'll multiply the 1 by 64 over 64. 64 minus 9 is 55. We got cosine squared of theta equals 55 over 64. Now I go ahead and finish getting cosine. We do the square root. Because we know we're going to keep the negative, cosine's negative in quadrant 2, I'm just going to put the negative on here. I'm not going to do the plus and the minus because we know it's negative. Right, so we do that and we get cosine of theta equals negative the square root of 55. Split up the square root of the top, the square root of 55 over the square root of 64, which simplifies to 8. So cosine of theta equals negative square root of 55 over 8. Right, now once you get this, you just use the definitions of all the rest. So the next part is asking for tangent of theta. You've got sine and cosine already. You don't need to really do much more work besides plugging into the definitions and simplifying them. Okay, so sine of theta is 3 over 8. Cosine of theta is negative square root of 55 over 8. And just like we talked about and saw last time, these 8s will cancel out if we do keep, change, flip. And we get the 3 over the negative square root of 55. I'm just going to move the negative out front. But that is tangent of theta. Box in our answers here. All right, now you can get, we got sine, cosine, and tangent. The rest come from flipping the appropriate thing. Secant is gotten by flipping cosine. Cosine is gotten by flipping sine. And just because I haven't done cotangent with the flipping thing yet, I'm going to do it by flipping tangent. Okay, but we're simply going to flip all of these fractions, the appropriate fraction, and that's going to be our answer. Okay, so when we flip secant, we got negative, or sorry, when we flip cosine to get secant, we get negative out front. That stays there. The 8 goes to the top, and the square root of 55 goes to the bottom. When we flip sine, sine of theta is 3 over 8, so cosecant of theta is 8 over 3. And when we flip tangent, tangent of theta is negative 3 over the square root of 55. Cotangent of theta, we got our negative out front, the square root of 55 over 3. And that is our answers. Once again, you can rationalize the denominator if you want. It is not a requirement. And these numbers, as you can see, don't match at all. So a lot of times when you rationalize the denominator, it really doesn't make it look cleaner. It actually makes it look messier most of the time. Okay. Pretty much the last main thing in this section that you'll see in the homework is doing trig functions on the calculator. We talked about sine and cosine on the calculator, and I showed you, and you'll see that there's a tangent button on the calculator. The one thing I have highlighted here that we'll point out, most calculators only have buttons for sine, cosine, and tangent. To calculate the other 3, you got to use the definition. Most calculators have sine to -1, cosine to -1, and tangent to -1 buttons. The -1 exponent stands for the inverse, not reciprocal. Right? So you cannot figure out cosecant of something by doing the sine to the -1 power of something. We'll have to do it the other way that I'm going to show you. Right? But this first one is just doing all 6 trig functions with the angle of 4.7. Keep in mind here that the angle here does not have a degree on it, so this is in radians. We must be in radian mode. Let's go to our calculator. Check out our mode. We're already in radian mode, which is good. And I know we're doing sine and cosine of 4.7. So let's do those first. Sine of 4.7 pretty much looks like -1. Where does it say it? Around 3 decimal places. 3 decimal places would put it at -1. You can put 0.000 if you want. Cosecant of 4.7, sorry, not cosecant, cosine of 4.7. Cosine of 4.7 is negative 0.012. Right, now keep in mind these are rounded. Right, they are correct for what it's asking, but it is rounded. All right, so to get cosecant of theta, we think about flipping sine. Right, the way you want to do that in your calculator, you don't want to take this number and flip this. Specifically, you want to flip the function itself, meaning cosecant of theta we can do as 1 over sine of theta. And if our theta is 4.7, this is going to be cosecant of 4.7. And we get negative 1.000 as well. And that makes sense when we flip -1. We should get -1, but you want to use your calculator and do it correctly. Secant of 4.7. Secant is gotten by flipping cosine. So we take our calculator and do 1 over cosine of 4.7. And we get negative 80.719. All right, the last two here, tangent and cotangent. There is a button for tangent, which is better than doing sine over cosine. You want to use that. All right, the reason is there's no issues with rounding because you're just doing the one thing. Cotangent of theta, what we're going to do to get that, instead of using cosine over sine, I'm going to flip tangent of theta, just like we did with the others. Okay, so tangent of 4.7 is about 80.713. And cotangent of 4.7 is 1 divided by tangent of 4.7. 0.012. Right, but that's the way you want to use it in your calculator. You want to use the sine, cosine, and tangent buttons, and then flip the appropriate one. Right, now the other thing I have here, you can probably fast forward. It's just me pointing out that you got to make sure you're in the correct mode. So if you're dealing with degrees, you just deal with degrees. I'm going to go through and just do this because it's in the notes, but all I'm going to do is the same thing, make sure I'm in degree mode. So we go back to degree mode here and leave. And our angle we're dealing with is 413 degrees. The sine of 413. 0.799. Let's go ahead and point that out. 0.799. Cosine of 413 degrees. 0.602. Cosecant of 413 degrees is 1 divided by sine of 413 degrees, which is 1.252. Secant of 413 degrees, 1 divided by cosine of 413 degrees, 1.662. Oops. And then tangent, we need to do before cotangent. Tangent of 413 degrees. I guess we don't do it before, but might as well. Tangent of 413 degrees is 1.327. And cotangent of 413 degrees, 1 divided by tangent of 413 degrees. It's 0.754. Now, one thing to kind of point out here, which would be useful going forward, when we get to certain topics, we talked about how sine and cosine are always between -1 and 1. Because cosecant and secant come from flipping them, if you flip a number that's between -1 and 1, it gets bigger than 1 or smaller than -1. So you're never going to see like a 0.5 here for cosecant. Tangent and cotangent can be any numbers they want between -infinity and infinity. They can output absolutely anything. It can be positive, it can be negative. So just so you're aware of that, these numbers all are okay. Your calculator's not doing anything weird. The last thing here is just there's not really any homework specifically on this. You kind of asked us in some questions when we did the earlier stuff with the unit circle. Figure out the four trig function values at an angle. But tangent's pretty useful to just know at the 30, 45, and 60 degree angle. So I have that outlined here. It all boils down to using its definition and the values you know. So we've pretty much gone over this. Tangent of 30 degrees, you get, if you simplify it directly, you get 1 over the square root of 3. But oftentimes you'll see it written as this. This comes from rationalizing the denominator. Either one of these is fine for me, but you have to recognize that they're both the same. And that's what I have written below. All right, the second one, tangent of 45 degrees. When the reference angle is 45 degrees, you get 1. But depending on the quadrant, it could be -1. And then tangent of 60 degrees simplifies to just the square root of 3. So like I said, you don't have to memorize this right now, but there comes a point in this class where you should recognize that these are tangent at the reference angle. So it's really not a bad idea to just memorize it now. If anything, think about the square root of 3 being in tangent. We got 1 over the square root of 3, we got 1, and then we got square root of 3. So that's the way it works. From the all students take calculus thing, tangent is positive in quadrants 1 and 3. The T is for tangent here. It is negative in quadrants 2 and 4. Right, but once again, there's not anything specific in the homework about this. These are just useful things to know going forward. But that is the end of section 1.3.